Hey guys, I wanted to make a video going over my summer project that I was supposed to finish as of today, um, but ran into a couple speed bumps along the way. So a while back, I decided to put some speakers in a school backpack for an incognito stereo system, and originally it was just kind of, just a fun little project I did. And it was fairly useful at the time because I took the bus to school and, we wanted to listen to music on the bus and there was a solution. But I never really expected to use it much past that. Well, it turned out I ended up bringing it to parties, get-togethers, we went to the park, and then now in college when we have tailgates or if we go to the park or whatever, it's a great little thing to have. Well, not really little, but bring it. You have great sound. It's loud. It's perfect. So I decided to do a complete overhaul on it, and initially I was going to build just a, standard-looking run-of-the-mill boombox with, those are the parts I had, and then just kind of clean it up a bit. And I was drawing it up in Inkscape, a vector program I used to laser cut. It also is good for measurements and whatnot. And I ended up settling on a new idea because I always like doing some new things. So I settled on this. So I will first show you the design process on the computer and then how I brought it to be. So this is the electronics portion. So the very first thing I did, let's see. Yes, I'm actually working on a website right now, so this is it so far. And what this is going to be is it's going to be a site where people can come, including yourself, and you sign up, make an account. It's completely free. There's nothing sketchy about it. And you go to the forums, and you can post, build blogs, you can ask questions. Basically a community for makers is what it's meant to be. So I got big plans for this. It's still under construction, so it's not live for you guys as of yet, but will be soon. So anyway, I've posted this build log in here just for the site and also just for personal reference. So here is the first concept photo. So you can see the symmetry was the thing I do prefer when I build things. In this case, this happened to work great for this design. So the idea here is you have your two speakers, but instead of pointing outwards in one direction, they're pointing at each other. And in between, there is a reflector. And so what this does is this allows the sound to be reflected a full 360 degrees in all directions. So you can put this in the middle of the room, you can put it in a corner of the room, you can put it at a park, you put it wherever, and there'll be even sound distribution in that area. And then beneath that, the subwoofer has its own sealed box, and then you have your amplifiers and electronics and what have you down here. So this was the very first 20 minutes into the design process. Just whipped this up. I literally just got these little images from Google and put this together in paint.net. So once I figured out what I wanted to do, I started drawing up some vector models in Inkscape. And here at UCF there's this great makerspace called the TI Innovation Lab. That's in the engineering building. And basically this is a place you can go. You don't even have to be engineering degree. And you have access to tools, laser cutters. You just basically bring your supplies and you have access to all these tools. There's people there to help you with your projects. It's fairly common among the engineering students because we do projects there for our introduction to engineering courses. So that's how I knew about it. But anyway, went there and got on this program called Inkscape. And let's see if I can hold this. Let's see. Alright, there we go. So the great thing about this is, number one, you can set your units and you can draw 2D images very effectively. but more importantly, it's a vector model. So instead of having pixels for the lines, they're vectors. And this allows it to be used on the laser cutter. So you can draw it up in here, and you can basically upload it to the laser cutter and have it print. So here you can see the electronics planning portion of it. So initially I was going to have one on Parts Express, which is a great audio source, and looked at some amplifiers. I was going to be using LiPo batteries, which are what are used in the RC community. And then I was going to have for the AC, when you have it plugged in, it would have a 12 volt, 25 amp power supply, which was pretty big. So did a couple revisions on this. I found out that although the LiPos have extremely high power density, like unparalleled, they are inherently unstable. And since this is going to be all put together all the time, I did not want to have any instabilities. If you're not familiar with the LiPo batteries, people build battery bunkers out of cement to charge these things in for when you're doing like the big ones, especially the big ones, which is what I would have used for, you know, RC trucks or drones or, you know, whatever kind of RC that requires very high current. I mean, these things will push, the ones I was looking at could push easily 100 to 150 amps. They have discharge ratings, and then you multiply that by the capacity or the amp hour rating to get your maximum and minimum. They have all these maximums and stuff you need to look at. But anyway, I decided not to go with those after looking at a video of them exploding in a thermite looking fireball. So considering this whole thing's made of wood, I didn't want that. So then I looked at lead acid, and that's too heavy, the power density's crap. I looked at nickel metal hydride, and those have memory and they're really hard to charge. They're not particularly power dense. And then I finally decided to bite the bullet and go with lithium ion. So unlike lithium polymer, these are very stable. In fact, these are a variant chemistry of these is what they use in the Tesla. I believe it's LOP4, something like that. It's lithium ion based. So I went with the standard 18650 size because I've worked with those in the past with, you know, I ripped apart laptop batteries and stuff for those. So unfortunately, the power required by these amplifiers is quite tremendous. So in order to get that power in such a small package, it had a bit of a price tag. So each one of the cells I got the Samsung, what the hell did I get? Samsung, here, I'll pull them up online, it'll be easier. They're all packed away. Let's see. This website had them. This isn't where I bought them from, but they did have them. The Samsung INR 18650-25R. And the great thing about these is, so their capacity is, I believe, 25 2500 milliamp hours. Their safe pulse discharge ratings are 95 amps for half a second, 65 for 1 second, but continuously, where was it? Continuously, you could pull, I think it was 5 or 6 amps. You could pull quite a bit out of these. So much that it would work for this scenario. So figured that out, picked those up, and those were going for about $5 or $10 a cell, something like that. It was a lot of money invested in that because I needed 28. So got those, and then I'm actually using power supplies for like a laptop to power the AC because they provide a nice DC output. And I didn't know this, but you can actually wire these in parallel to, you know, like obviously you can wire batteries and stuff in parallel, but I wasn't sure if you could parallel switching power supplies. You can. So I did that. I have 4 90-watt power supplies in parallel at 20 volts, and the battery packs will be ranging between, I think their rating is 27 or 26.5 volts, something like that. But it ranges between about 20 and 30. Is about where it is. So from there, this was the final configuration I settled on. And let me pull up the other one. I think I have drawn up in here. So here is the prototyping process. So this is the speaker enclosure. I'm going to get back to the electronics in a second, but so this is the prototyping for the speaker, and I want it to be modular. So as you can see there, those slide up and down. So this is a quick little clamp together, just to see if it works. And there's a subwoofer like that. And I was testing clearances, so I was just doing a woofer excursion to see if there was any noise generated by having something right above it, and I found that about an inch, a little bit less than an inch of room is plenty for this particular sub. Then I started working on the reflector. So this piece is kind of hard to see, but I guess at this angle it's not. This is a lot shallower than, or not shallower, it's less sharp of an angle, I guess. It's less steep than the bottom one. So I was testing to see how that would affect the sound, and you really do need the steep one to get clarity. So I ended up going with that. And then here you go, you can see I finalized that and started cutting out these parts. So I cut out a bunch of triangles, and then these little mounting pieces here, made them in pyramids, glued them together. And here I just have those two pyramids taped on just temporarily, and that's in their Cricut just so I could easily remove it. Tested it out, worked great. And then yep, here's the electrical, you already saw that. Here we go, this is what I wanted to show you. So did the front layout. So how this goes together is there are 3 assemblies. So you have your power delivery, which consists of your battery, your power adapters, and all the stuff needed for that. So your AC, your battery chargers, your battery management boards, everything. So that's all on here. That slides into the bottom like this, because right there's posts. So this is a sub box, but so like here you see how you can slide in that way and you can slide in this way, but if you had a square this size you wouldn't be able to do it because the corners are cut out for these posts. So this assembly slides in. I just passed it. Sorry. So this assembly slides in, and then that gets mounted, and then this assembly, which is the amplifier assembly, slides in as well through this assembly. So it's kind of hard to see, but there's notches grooved out. It'll make more sense when I show it to you in actual hardware. And then this plugs into the back panel, I guess is what I called it. So I have my regulators on there, which consists of a boost and a buck converter, because one of the amplifiers requires 40 volts instead of 20. The other one's happy with 20. And then some of the other small electronics, like the crossover and the Bluetooth, require 12. So that regulates to 12. And these are especially good for the batteries because although the amplifiers are happy with the range, the small electronics are not. They need 12 volts. So that regulates that. And then here's some other parts for other stuff. So this is the assembly here. You can see the notches for the amplifier to slide in, and then these are for the power supplies, charger, batteries, wires, etc. So then I cut some notches in the corners for the wires to run up to the speakers. And here is the general circuit diagram. It's not really drawn as a circuit, but it's just drawn, laid out so I can plan it. So this is basically what is happening. As of now, this guy here, the battery charger, the battery banks, or battery packs, and the protection board, none of those are hooked up, nor is this switch. Basically what I have right now, I have the Bluetooth, the amplifiers, the speakers, the buck converters. This is actually, I had to modify this. There's an extra buck converter in here, or a boost converter for this amp. Those are all hooked up to these guys. I have not touched the batteries yet. So then here's a little battery thing I worked on. I made a little holder. Now that, see how thin that is? This is not designed to support it. It's just meant to space them. And then just tape that together. Here's the amplifier. This initially had a fan on it. I took it off because of clearance issues, and they run surprisingly cool considering how small they are and the wattage they provide. So there's an assembly of it. You can see how that slides in, and then these little notches, or little I guess, feet. Those had to be sanded off to fit. And there's my power adapters in there, so that's the power delivery system. That's empty, and then here's the amplifier assembly. This is pre-Bluetooth and crossover and everything else. So that's where I left off on here. I'm going to be updating this. If you guys are interested, I will put a link in the description as soon as this website is at least somewhat available. I might just do it regardless, but anyway, watch out for that, because that'll be a real good place to go if you're interested in building things. So yes, here we are. So got all those speakers mounted. I actually came up with a kind of clever little design for these wires. So I wanted this to be modular, right? But I needed to connect the wires to them, and so these will run down here, and eventually I'll have wood pieces that just probably just snap on or something onto here. So if you want to remove these, you unscrew the little screws on the corners, take that panel off, and then that's not good on that. So yeah, that one, this one's actually being supported by those wires right now because I don't have all the screws in, but this one's not. So you can see I just have a little mono 3/8 inch jack going right in there, and that lines up just like that. There's a little hole there, but no big deal. And that just slides right in and snaps right in, and that completes the circuit. And then here is the amplifier and boost converter thing. So you can see I have little connectors there, so this can be pulled apart. This assembly is entirely connected through those. So one of them is strictly power, the other one is strictly speakers out. So that's all handled by this board here. And then this board, all this needs is your voltage in. So in this case it's 20 volts because I'm running off of just 3 of these. That's plenty for that. I have 4 because I might upgrade one of the amplifiers to a higher wattage. In fact, I probably am. And then there it is paralleled and coming in there. And then once it gets in there, regulates 20, boost to 40. Got your crossover here set to, I believe it was 125 hertz. 80 was kind of low, 250 was too high. Actually, it was set to 80, so 125. I have to sand that down a little bit to make it fit. And then I have a mono summing cable here I made with a resistor, or a couple resistors. If you're interested in making this, look it up on Google. There was a guy on a forum that had a nice circuit. And then there is the Bluetooth receiver. Now I don't actually have a 3/8 inch jack in because devices have different levels that they output. Like an iPhone is a lot less than a computer. And since I wanted to set the gains to as high as possible without clipping, if I set that to my iPhone, then it would clip on a computer. And if I set it on my computer, then the iPhone wouldn't be nearly as loud as it should be. So to just completely get rid of that issue, I'm using the Bluetooth temporarily. I'm going to keep that in there regardless, but I might add some kind of regulator, like preamp or something in here later on. But for now, the Bluetooth works just fine. So here we go with the demo. The fans are kind of loud because I don't have any kind of any resistor or potentiometer in there right now. I'm going to have them adjustable at some point, but right now they're just running directly off 12, so just kind of ignore those, I guess. So here we go. So you can see the fans come on, that Bluetooth will blink, and it's just connected, so it's solid. And then we got the amplifier there. That's the 2 by 100 watt that powers those two guys. And then the 1 by 300 watts powers the sub. And that one's a little underpowered for this guy, so probably going to pick up the 500 watt, the exact same amplifier, just 500 watts. And these amps are great. This is Shure Electronics. This was 30 bucks, this was 40, the 500 watt is 50 bucks. I'm just going to get it and just switch it out because it sounds great right now, but it's probably getting, it's 300 watts at 3 ohms. This is 4 ohms, so it's probably getting less than 200 because I've run it conservatively. So yeah, everything will support it, so I'm probably going to get the 500 watt, but let's see what she sounds like. So come over here. It actually just connected to my computer via Bluetooth. So if we go to the devices, there you can see the Shure Hi-Fi Stereo is what I named it. So that's default. If we come here, you can hear it over there. Oops. So I'll do just a general song, and then I'll do like a bassy song. So we'll do The Handler by the new Muse album first. And the subwoofer is not connected. Let me fix that real quick, hold on. Yeah, these connections are coming loose on this guy because it's not mounted properly. It's not in its enclosure yet, so let me fix that real quick. Okay. Yeah, this won't be an issue once it's in, but just because I have it balanced here, it's an issue. Alright. Let's try that. There we go. That's better. Oh yeah. Having a little connection issue because my laptop's way over here. I'm in the way. Yeah, you know what? I'm gonna switch to my phone. This was working fine before I started recording, of course. So I'm gonna show you how you disconnect from this guy. So you literally just go here and disconnect, and then disconnect from both of those, and you'll see that that guy is flashing now. So yeah, it might just be how I had this angled because I did move it. It might be giving me issues. So now I'm just gonna go on my phone, turn on Bluetooth, and it should auto connect. If not, I'll go to settings. Yeah, it looks like it's not. Usually if you turn it on, your Bluetooth on your phone, it'll automatically connect. If not, you just come here, tap it, and we're good. Simple as that. So, no, I don't think I have Muse on here. So we'll do Interstellar instead. So this is Mountains from the Interstellar soundtrack. I'm just going to skip to where it starts going somewhere. The thing with the soundtracks, especially by Hans Zimmer, is that there's so much dynamic range. And again, this is playing from my phone. This will have a good connection until about, I'd say about 20 feet, but I mean, that's not really an issue for me, so. I'll do the Batman one too. There we go. Lovely sunny day in Florida. So, as you can see, it works, so that's a plus. Now I'm just going to try to play something loud, because those, I think those songs were actually scaled down to the dynamic range, so let me set my nose loud. Let's see. I guess there's some trap. There we go. So, as you can see, and I can control the volume right from here. It's pretty sweet. So, as you can see, it's coming along. I just have to do the batteries and some other stuff. So, but yeah. So, thank you for watching, and more videos coming. So, catch you later.